Hello, my name is Xander. Welcome back to the Python Beginners course. In this module, we learn how to utilize the for loop. This is module 8 of 10 of the Python Beginners course. If, of course, you have missed any of these tutorials and you want to go back, there is a link in the description. So take yourself back to any module that you want to complete. We will be utilizing the skills that we've learned from previous modules in this tutorial. So if you have missed anything, and you do want to go back, like I said, you can go back to other tutorials. In addition to this, of course, if you have a look in the video description, you'll find a link to the code source for this tutorial and all of the tutorials in this course. The for loop allows us, or can be used for iterating over a sequence, and that could be a list, a tuple or tuple, a dictionary set, or string. So this initial opening statement, it might not make any sense to you, and that's absolutely fine, because the whole idea here is that by the end of the tutorial, hopefully you have a better idea what it is when we say that we can iterate over a sequence. So let's just put this idea into action. So we have Visual Studio Code open. I've got my example.py like in previous tutorials. So let's go ahead now and create a for loop. Right, so we're going to need for, and then for, in this case, I'm just going to use an arbitrary letter, in this case, just X or I, for example, in, and then this time we're going to use a string, so hello. Right, so we need the colon, and then let's not forget that we're going to need some white space here. Here I'm using for. Make sure at least you're using 1, remember? So indentation here, or white space 1. So I'm using 4, so you can see that Visual Studio Code is set up here for 4. Okay, so that's important, remember. Right, so now let's go ahead and print I. Okay, let's have a look to see what the outcome is. So here we can say that we're iterating over a string. So if we remember back in the string module, we found that a string in Python can be described as an array of bytes representing these Unicode characters. So essentially what we found out in the strings module is that we could individually select or slice or select a number of letters from a string and return them. And we gave this idea of each string had or was indexed, and we can access it from its index number. So here in this case, this string hello, we could access just H from the index 0 position. So let's take a look at this in the most fundamental way. This was our for loop here. Now I have some of the syntax missing here. But you get the general idea from the example we've seen initially. Now, what's happening here is that essentially the hello, or the string here, is broken into its individual components. And what we're doing here is we're iterating over this string. So for each element, or each part of this string, say, we are essentially taking the individual component. That individual component we can say goes into X, and then we can reference X within the for loop. In this case, we're going to print it out. So the outcome here is that the H will get printed out to the screen. Or to the terminal, sorry. Okay, so we're iterating over this string. So what happens now, we've iterated over the H, so let's go ahead now and iterate over the E. So in this case, we now take E, that goes into X, and then we print out X. And then we do the same thing for L. And then we go to the next step, and then we go to the next item. Of course, once we get to the end, there's nothing else to iterate over, and therefore the loop finishes. So the outcome, as we've seen here, is 5 lines of the letters that correlate to the string that we've asked to iterate over. So as I suggested, this I is just a reference point, so I could just change this to anything I liked. At this point, it's just a way of then accessing whatever is being iterated over the individual items at that particular point when we loop through. So at this point, we've got the general principle. So we can change this up. So I mentioned before that we can iterate over a string. In this case, we have a list. So the principles are the same thing here. There's items within this list, and one by one we're just going to print them out. So we're just going to loop or iterate through this list and just print them out one by one. So if we just run this piece of code, you can see that we output A, B, and C. So we have a similar setup here for dictionaries. So let's just iterate through our dictionary. So you can see that initially what we loop through here, what we iterate through here, what gets printed out is the actual key and not the value, in this case with a dictionary. So let's go ahead and select our values. So X is just referring to our dictionary stored here in our variable. So let's go for dot values. So this is what we were learning in the previous tutorials when we discussed tuples, dictionaries, and lists. So let's go ahead and do that. You can now see I'm selecting the values and iterating through just the values. Now, I could also do potentially the same with items. So let's give that a go. So you can now see where it's selecting the individual items. Right, so you'll notice in actual fact in this case, there's two parts of this dictionary, which we know, the key and the value. So we can output either the key or the value or both. So what we can also do, for example, if we were to, for example, have I or just A or B, let's do A and B in X items. Remember, items is selecting both elements. Now there's two elements here, so we can break that down further into A and B. So what's happening here, for example, this first key pair value, the 1 is then going to be referenced by A, and the A string here is going to be referenced by B. So if we were to now print this out, for example, or just A and B, let's have a look, and there we go. So we have a similar situation here, but we're able to access both these values or components here inside of this key value. Okay, so there we have some basic principles there and examples of iterating over lists, dictionaries, and strings. So what I like about what some might describe as basic knowledge is that although this might seem really basic that we can perform this type of action, the reality is that we can do so much with a for loop and just utilizing the skill set we've learned so far. And we'll have a look later at applying this, of course, in some of the challenges. So let's now have a look at utilizing a for loop with range. So this has got a lot of applications. So this example here, we've got the for loop, so we've got I, so we're going to use to reference the data with I and print out, the iterate and print out the individual components with I. And then we've got a range, so 10 to 0. So if you remember from previous tutorials, we've utilized range. That allows us to specify a range of values. So in this case, it's going to be 10 to 0. And what we're going to do here is on each iteration, because remember, range is going to get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So here what's going to happen is that we're going to -1 after each iteration. So you probably can already see what's potentially going to happen here is that we're going to end up with a nice list here from 10 all the way down to 1. Okay, so we're just minusing 1 every time we iterate over. So the first time we call range, it's going to give us 10. And then the next time we're going to -1, that's going to give us 9, and so on. So that gives us a nice countdown. So that can be really useful. For example, if we knew that we wanted to loop through something 10 times, for example, or 5 times, we could use range in order to control how many times we loop through and perform an action. Because that's something we've not spoken about yet. The fact that, well, what can we use a loop for? Well, we can use a loop to control an action or to iterate over something a number of times that we wanted to. And we're built towards that. But let's just give you a few more examples here utilizing range. So let's just do that the other way around, for example. So 0 to 10 if you've forgotten how range works. So let's just count in 2. So even numbers. There we go. So 0, 2, 4, 6, 8. Right, so you're probably getting the idea here. Let's move on slightly here and provide a slightly different example. Right, so let's go ahead and just go for a range 0, 4. Right, Okay, so now what we can do is let's set up an input, for example. So input, give me a number. Right, so what we're going to do here, you may have guessed, is that we're going to iterate over this range. There's obviously a set of numbers here it's going to iterate over, 0, 1, 2, 3. And each time we're going to be asked to input a number. So let's just give this a go. We could go ahead and print X or I. Let's just print I actually, yeah. Okay, so let's give this a go. So give me a number, 1, 2, 3. So you can see the iteration 0, 1, 2, and then the last one there, 4. Okay, so that could be pretty useful potentially. Now, in addition to maybe iterating over a number of times. So for example, we wanted to build a game where we had to guess the number. This could be really useful in that we could keep iterating over this until maybe someone has actually selected a number. Or we might want to, I think we've made this game before in a previous tutorial. So we've asked the user to type in a number a few times to try and guess the random number. And after the third time, for example, we tell them that they've lost or they didn't guess it correct and they need to try it again. So take, for example, this. So let's just pretend that x equals 1. Okay, so in this case, we can now do if x, for example, is equal to 1. So this is a string, so I'm just going to add this as a string. Let's just print you won. You guess right. You guess right. There we go. So there we go. So we are going to iterate over 3 times. If the user does select the right number, then we're just going to say you guessed right. So let's just give this a go. 2, 3, and then 1. There we go. You guessed right. So notice that although we did guess right, we still have one iteration to move through. So we're asked to do that and we have to do it. So the question is now, well, how can I stop a loop? How can I stop the for loop? Because that could be an interesting control. For example, in this case, you can see that when the user does select the right answer, we do want to stop the loop because the game's over at that point. So first of all, let's introduce break. So stop or break the loop before it has looped through all the items. So here we're going to use the keyword break. Sorry to repeat myself, to stop or break the loop before the loop has looped through all the items or iterated through. So let's have a look at this. So key to this is the word break. So for example, if they do correctly guess, let's just use the word break. So let's give this a go. So let's just guess it straight away. There we go, you guessed correct. So now you can see we're not looping through. So if I select the wrong answer, you can see that we're going to keep looping through until we get to the end. Maybe I select the right answer and there we go, we can break. Even though in this case, that was the last iteration. Okay, so another control we have here is continue. So this is going to start the next iteration. So the keyword continue here, if we use it, it means that we're not going to continue looking through the rest of the code. We're just going to start the next iteration. So let's have a look at this. So let's just explore this example here. Now, maybe you can pause and try and work out or try and think what will be the output of this program. So if we read through this, we have a list here of integers 1, 2, 1, 2, 1, 2. So for I and x, so we're going to iterate through this list. If I equals 1, we're going to use continue. Now remember I said continue was going to then start the next iteration. And then we have a print. Okay, so essentially what I'm suggesting with continue is that if I is 1, so for example, we iterate through here, the x, that's going to be, the first item is 1, so if I is going to be 1, so if I is 1, we're going to continue. So what we're suggesting here is that print isn't going to be initiated because we use continue and it's then going to go over to the next iteration into 2. Now if I doesn't equal 1, in this case it doesn't with number 2, then we're just going to move on and print it out. So let's give this a go. And there we go. So for every time we match 1, we use continue. And notice we don't then Python doesn't get down to print because we've told it to continue to go to the next iteration. Now, when I equals 2, of course, we don't run this piece of code, and then we move on to print and print it out. Okay, so hopefully you've got the general principle there of continue. For us to really understand continue potentially, we need to apply it into a situation or an example. So maybe you can think of something where you might need to, or where you could utilize continue. Maybe we can utilize it in our challenge at the end of this module. So similar to an if statement, what we also have with our for loop is else. So we can use an else. So for x and I, print I, okay, else. So when we get to the end of the loop, or when we break the loop potentially, let's do something else. Now, I did say potentially there. So else print, let's print end, for example. So let's just give this a go. There we go. So we've looped, or we've iterated through this list, and then we get to the end here and we print end. Now, what happens if I, for example, break here? So iterate through the first item, I'm going to break straight away. So let's give that a go. Notice what happens here is we exit the loop, and then we don't print the else component here. So that's important to understand if we were to utilize a break here within a for loop. So we could potentially say loosely that this else is part of the for loop. So we are utilizing break to end the loop, so therefore we don't run the else, which is part of the loop. So that can be a handy tool to have when we want to output something at the end of a for loop. Right, so let's move on now and talk a little bit about nested loops. So this is a loop. Okay, so a nested loop. So here we're going into the idea of a loop within a loop. So here I have some data, two lists, A and B. So what I want to try and do here is, for example, I want to loop through both lists. I want to iterate through both lists. So let's go ahead first. So for I in A, apologies for all these names here. So for let's go for X, right? So for X in A, in our list, we're going to print out X. Okay, let's do this first and just build this up. There we go. So we just print out all the ones. So now what we want to do is we want to loop through B as well. So for Y in B, so B being our second list here, let's print out, in this case, Y. So it's the same principles again, moving into the Y and then printing out Y, except for we're nesting this for loop within a for loop. And just be careful to make sure you've got the indentation or the spaces correct and they're consistent. So here I'm using 4 spaces. Right, so with that in mind, let's have a look to see what happens. So that's very interesting. If we just look at the result here, you'll notice that first of all, we print out 1 and then a set of 2s, the list, then a 1 again, then a set of 2s, then a 1, then a set of 2s, and so on. So what's happening here, we try and follow the process here, is that first of all, our for loop, X and A, so we take the first iteration of this list here in A variable, and we print it out. Okay. So then what we do is we say for Y and B. So this is we're going to iterate over the list at this point. So we do this once, and then we perform the next action. So this next action just happens to be another nested for, and we're going to then fulfill and run the whole iteration. And then once we've done that, we go back and notice that A, we've only iterated once, so then we iterate again. And then we go back and then we iterate over the 2s again. So that is what's being outputted. So we iterate over A 6 times, 6 once, and for each iteration of A, we print out the 6 2s. And that's what you saw in the output. So it's interesting what we can do here. For example, let's not print out X here. So we still have X throughout these statements here, so we can utilize it potentially here. So we could print out X and Y together in this case. Remember, X is iterating over the A list and the Y is iterating over the B list. So let's go ahead and have a look to see what this looks like. And there we go. Now, if you count up all of these outputs here, there's 36 items. So the same situation applies here, in that what's happening here is that we're looping through A, and we're looping through essentially the whole thing 6 times. Now, for each item in A, and there's 6 items in total, we loop through first, and then we go ahead and print out X, which is 1, and then 6 Y's. So 6 times 6 is going to be 36, and that's why we've got 36 outputs. Okay, so there's a run through of the basic functionality and features for a for loop. So let's go ahead now and have a look at some code challenges and apply this. On to the first challenge. Let's have a look at building this up. So this first challenge is going to be a fairly small challenge, and then we're going to go for a fairly large challenge. Right, so first of all then, let's randomly create a number between 1 and 20. So this is going to be a guessing game. You can change the range, of course. Now let's ask the user to type in a number between the number range we have selected, in this case 1 to 20. So the user should be given 4 turns or chances to guess the number. Now let's just, you can do whatever you like at this point, but in terms of output, just think of something that would be relevant. So for example, maybe we want to, when the user types in the wrong number, we might want to print something. That's a wrong number. Try again, for example. We could also, for example, just before the last guess, let's print out something to tell the user it's their last guess. So remember here we have, we're given 4 turns or maybe 3 turns. Again, you can choose your preference there, how many turns. I'm just going to go for 4 turns. So on the 3rd turn, we're going to tell the user it's the last turn. So by all means, have a little go to see if you can do this. If you need more information, have a look at the GitHub repository code. I've kind of given you a little bit more information in terms of the output that you might want to use. So let's have a look at a solution. Now, your solution might be different to mine. If it's working, that's absolutely fine. I'm just going to try and utilize the code that we've utilized so far, or we've demonstrated or used or explained so far. So let's first of all import random, because we're going to need to make a random number. So x equals a random dot, and then we're going to use an integer in this case. So let's go for 120. For example, I'm just going to cut this down 1 to 5, right? And that just makes it easier for me to guess. Right, so now we want to allow the user to have 4 guesses. So let's do a loop. So for I in range, so we're going to use a range here, 0 and 4. So 0, 1, 2, 3. So there's 4 chances. 0, 1, 2, 3. Remember, we're counting from 0. Okay. And then we're now going to, first of all, indent. So let's use some spaces here. Y equals integer. So we're going to ask the user to input. So this is going to be an input. And we're going to ask them to guess a number. So at this point, you could say guess a number between 1 and 20. So this is just for demonstration purposes only here. So guess the number. There we go. So I'm going to need a colon there. Right. Okay. Right. So now I can add some logic if you like. So if, for example, if I is equal to 2, then I'm going to print that it's their last turn. So this is your last guess. There we go. Okay, so if I equals 2, now remember 0 is the first turn, then 1, and then 2, and 3 being the last in this range. So on the number 2, when we iterate and I is 2, then I'm going to print this out because that's going to be their last guess after this. Right, so let's now go ahead and run if statement. So if x, that's a random number, is equal to the input of the user, y. Then we're going to print something. So let's go ahead and print you guessed correctly. There we go. So I could also say the correct. So let's use F here. So the correct answer was, and then that's the random number that was generated. Excuse me. So that the random number was X, variable X. There we go. Right. So that's that. Now remember, if the user does select the right answer, I want to break. Yep, I want to just close the loop because I don't want them to guess anymore because they've already found the answer. Okay, so let's just give this a go. Let's open up. So I'm going to open this up. So I'm using control and comma. Yours might be slightly different. If you're not too sure, go to view and terminal here. So control plus single quote, or in my case it's comma. So now we've got, let's have a look. Let's give this a go. Okay, so we're missing one positional argument, B. Right, so let's have a look where that is. X equals, oh, okay, of course. That should be a comma. Apologies. Okay, so let's guess a number. So let's guess a number, 1. Okay, it's not the right number. 2. Nope, 3. There we go. This is your last guess, and it says now you guessed correctly. The correct answer was 3. So you can see there's some ordering difficulties here in that, for example, this is your last guess, and then it instantly says you guessed correctly. So if we look at our code here, you can see what's happening. So y equals guess the number. So when we iterate over, first of all, we ask the user to actually input the number. If I equals 2, print, this is your last guess. So somewhere here, we're going to need to potentially maybe run this first. So let's just think about the sequence here. So if they have guessed correctly, then we say they guessed correctly, and then we break, then we don't run the print. This is your last guess. Okay, so let's just give this a go, see if this works. 1, 2, and there we go. So now I've guessed correctly. It now just prints you guessed correctly. The correct answer was 2. And then notice we've used break. So we exit the iteration or the for loop, and then we don't print out this this is your last guess. So that in short is what we've got here. So what we could also do, for example, is we could run a separate if statement here. So if y is not equal to x, let's print something. Let's do that. So 1, 2, 1, 1. And you can see here at the end, if y is not equal to x, we're going to print, sorry, the number was x, for example. So that doesn't need to be an if statement. I've just put that in place there. So there we have an example, a final example, utilizing a for loop here with some if statements, some variables, and utilizing break to build the simple game that we explained in the challenge. So like I said, your code may not be exactly the same, but if it's working at this point, very well done. So let's now apply this knowledge to code challenge 2. This challenge is a little bit larger, and this is probably the largest challenge or potentially the largest script that you're going to have built at this point. So in the previous module, we have built a rock, paper, scissors game. So we're going to copy the code from the previous module, and let's now expand and adapt this game so that the winner is the best of 3 games. So far we've created a rock, paper, scissors game whereby as soon as you win 1 game, you've won. But now what we want to do is run this so it's the best of 3 games. So it's the first person to win 2 games will win the overall game. So ultimately here, we need to think about how this is going to work. Now, the maximum amount of games that we're going to run is 3. That's important. So potentially we're going to iterate over 3 times, or a maximum of 3 times. So the first person, the user or the computer AI to win 2 games wins overall. Right, so there's a few bits of logic here we need to think about. So maybe just write this down. Think about the flow of the system here. Think about when the system needs to break. Think about, for example, the conditions of the win condition and what needs to be done if a user does get to 2 games or wins 2 games. And potentially here, what we also need to do, something we've not done so far, is, well, how are we going to store information about how many games the user and AI has won? So here we're potentially going to need to make a new variable and store that information. So the best thing here to do is just have a think about the system, what is needed here. I've given you a few tips here, and try and give it a go. Try and have a go at trying to build this. And it might take you 15 minutes, it might take you an hour, but it's well worth going through the process before I provide you, or you look at the solution. So I'm going to start off with the code which we finished up in the last module, module 7, Tuples list and dictionaries. So you'll find this in the challenge 1 solution in that module. And I've just copied and pasted the code over. So let's just double check to make sure this is working. So you can see here what we need to do is type in 1, 2, or 3. And then the CPU choice was paper, our choice was rock, and we lose. Okay, so let's give that again. So scissors and paper, we lose. And then paper and paper, we've drawn, we can't seem to win. There we go. So the CPU selects rock, we've got paper, we win. So let's just work from the top here. So we're going to need a random choice. So let's just make sure that we've got this. And obviously we're going to need our item list still. Sorry, let's just start there. So we've got the item list as per normal. Right, so here, as I suggested, we're going to need to store the AI score, so the computer score, and then we're also going to potentially need to store the user score as well. So we're going to start at 0. When the user wins or when the AI wins a game, that's going to be incremented by 1. When it gets to 2, we know that either the computer or the user has 1. So that's how we're going to keep track of the score. So we know that there's going to be a maximum of 3 iterations. So for x in range, so 0, for example, to 4. Okay, so there's going to be a maximum of 3 iterations. Okay, so we're going to loop around 3 times. Right. So when we loop around, the first thing that we probably want to do is check to see if someone's won. So let's do that first. Now, let's first of all check the AI score. If it equals 2, the AI is 1, right? So let's go ahead and just print out AI wins. Okay. Now, if, for example, or we can say else if the user score is also or is equal to 2, then we're going to print something else. So we're going to print the user wins. Okay, so that's in place. Now, if someone wins, remember, what we want to do is break the loop. So let's use this keyword break. Okay, now then, there's a third condition, remember. If we get to, for example, the 3rd iteration, we probably want to maybe print something out. So let's do else if. So remember at this point, it's our 3rd iteration. So either the user score is going to be 2, or it's, for example, there might be 3 draws, in which case each of the users here will have a 0 score. So after the 3rd iteration here, the 3rd game, we want to just output something. So for example, if x is equal to 3, remember x is the range, the number of range, so 0, 1, 2. So if it, for example, gets to 3, then we know that we're on the the last game has been played already, in which case the game should close. So let's go ahead and just print out something here. The game is a draw. Okay, so there's 3 games, but you can see here I've got 4 iterations, 0, 1, 2, 3. So that's 4 iterations in total. Now, that might be confusing here because I've got 0, 4. Remember, we're counting 0, so 0, 1, 2, 3. So when the range is 3, we're going to capture that 3 because we know that we shouldn't play any more games, and we know that the game is a draw if no one has won. So if the AI and the user hasn't got to 2 games, win games, then we know that this iteration here, the 3rd iteration, or the 4th iteration, but the number 3 in the range, then it must be a draw. So we're then going to also break, and the game ends. So you can see there's a little bit of logic, a little bit of thinking here that needs to take place in order to get this right. So if you haven't got any of this and you're just going through the solution, don't worry. It's all practice. If you have got it, then congratulations. So like I say, if you haven't got it, don't worry. It's not a problem. This is just all experience. And the more examples you go through, obviously, the better you'll become. You're just going to be building up a library in your mind of all the different ways potentially you can utilize these tools that we've been moving through, these different modules. And then, of course, over time, this will just become second nature, and you'll be working, your brain will be working in a way that helps you build or develop this type of logic. Now, it might be, again, that you have created a set of completely different code, but it still works, and that's absolutely fine again. Right, so now we're going to ask, remember, first of all, we're going to check this on each iteration, check the score, and check to see if the game is over. Right, so now we've done those checks. Now, if those if statements aren't matched, it means that we're going to play a game. So the first thing we need to do is take in a choice, right? So the user's choice. So let's just convert, or let's just cast that into an integer. So we're going to create an input type, oh, it's just here in actual fact. So type in your selection. So let's just take that, put it here. So now we're going to take in the user's choice. Cool. Right. And then the next thing that we're going to do is get our random choice. Okay, so just the code we had before. So now we got the user selection and the random choice. So all we need to do now in actual fact is, let's just remove that, is just run through this again. And this is all the conditions. But what I'm going to do here, let's just cut this down a little bit. So I did mention this is something you could have done in the previous. So there's no point us having a look at the draws here. So let's just get the draws. There's no point doing that 3 times. So we can just we can do that with just one statement, right? So let's just remove all the draws. Right, that cuts down our bit of code here. And what we can do here, for example, is just say if item list choice. So that's the user's choice. If that equals the random choice. So if they're the same, we know it's always going to be a draw. So let's just always print draw, for example. Right, so the rest is all the same. So all the other ifs, so we're going to check all the different conditions. Let's just get rid of the print at the end here. Okay, because what's going to happen here is that we're just going to print the game as a draw at the end. So we don't need that anymore. And well, let's just give this a go, I guess. Right, so let's give it a go. So typing selection 1 rock, you win. Right, so behind the scenes, I should now have in my variable here at the top, the user score should be 1. Right, so let's type in 1 again. So I draw. So I've got 1, the AI has got 0. So this is the last game. So if I win this, okay, so I did win this. So I win 2 games. And now it says the game is a draw. Okay, so let's take a look at why that is. So what should have happened here is that if the user score was equal to 2, which it should have been because I won 2 games, then I should have printed out user wins. Oh, okay. Apologies. I think it was okay. So no, user wins, but it just says you win. And then we've got the game as a draw. So it seems to be going down to this condition here. So let's just try this one more time. So my selection is 1, so I drew, and then I drew again, and then there's another draw. So the game is a draw. So that looks to be working okay. So let's try this again. A draw, I win, and I lose. So the game is a draw. It's 1 each. Okay. So rock, you lose, you win, and so you can see here I've won twice, but the game is still a draw. So there's a problem here. So you may have spotted the problem. When we play the game and we print out a result, we're not actually doing anything. We're not actually updating our variables. So what we need to do here, depending on the outcome, is we need to update the variables. So for example here, if we lose, it means the AI has won a game. So we need to increment the variable by 1. Now we can do the same thing again. So when we win, we need to increment the user score by 1. So let's just go over all the win conditions and just increment by 1. And then with the, if we lose, so we lose here, we lose here. So let's increment the AI and we lose here. So what we're doing here now is actually controlling the scores. So that's how we're going to keep track and increment by 1, so plus equal. So we're going to take whatever's in the variable and we're going to add 1 to it. So now let's give this a go. See if I can get a win condition. So draw, win, win, and there we go. So the user wins. So we can add to this if you wanted to, if you wanted to think about some other skills that we've learned. So for example, here, if I type in A instead of 1, 2, or 3, you can see that we're getting a value error. So we learned previously, although we didn't formally go over this, we learned that we could use a try except, for example, to kind of capture that. So let's go into our input here, and I'm just going to copy and paste this in, right? So with our choice here, we can convert that into a try except. So try choice, and now if there is a problem, in this case a value error, we're going to capture that value error and we're going to print something out. Okay, and then we're going to break again. Okay, so let's give that a go. So in this case, whatever. There we go. So you did not enter a valid option. Please try again. So we can capture that value error and control it and deal with it sensibly. So there we have an introduction to the for loop. Hopefully the examples or the challenges there were interesting and also challenging, of course. That last example, like I previously said, that's probably the largest piece of code that we've written so far. So I'd be interested to know how you got on, whether that was useful, whether it's too hard, whether you felt as though that you needed more challenges. Now, you might look in the GitHub repository. I will keep updating it with new challenges, etc. So by all means, head over and you might find some more challenges if you want to practice further. Thank you very much for listening. Hopefully this was useful, and I hope to see you in the next tutorial.